The last thing we're going to be doing in Chapter 2 is proving angle relationships. We're going to be introduced to a few more different theorems, like right angle congruency that says all right angles are congruent. You're going to be shown congruent supplements, congruent complements, more geometry theorems that we're going to use inside a proof. Let's look at this one right away. Theorem 2.3 says that all right angles are congruent. Now that makes sense. If we even look at the definition of a right angle, it says that it equals 90 degrees. Well, if all right angles equal 90 degrees, then all right angles are congruent. That makes sense. But now we're using it in a proof. What we have to prove is that angle 1 is congruent to angle 2. When we do that, we're done. And what we're given, notice how we already have given written down, is that angle 1 and angle 2 are right angles. So again, here we have our 2-column proof, steps, reasons. Again, we're just jumping right into proofs because the best way to get better at them is just to practice them over and over again. Eventually, you'll do proofs so many times that you'll see the path that you have to take in order to prove something is true. Angle 1 and angle 2 are right angles. Right away, I want to bring out the definition of right angles that says that angle 1, if angle 1 is a right angle, then angle 1 equals 90 degrees. If angle 2 is a right angle, then angle 2 equals 90 degrees. And that's just using the definition of right angles. Well, now I have two true statements that I can cross off what's being used. I have angle 1 equals 90, angle 2 equals 90. I'm going to cross off the 90 here, and I can say that angle 1 equals angle 2 by the transitive property. Then, if angle 1 equals angle 2, I can say that angle 1 is also congruent to angle 2 by the definition of congruent angles that says if two angles are equal, then they are also congruent. And at that point, I am done. A very short proof, but a good proof that helps you get better at proofs. Now, don't get me wrong. Proofs aren't easy. But you'll never have a proof that's like 13 or 14 steps. Okay, a long proof is like 5 and 6 steps. So don't worry if you're feeling overwhelmed. Proofs are not going to get a whole lot bigger than this. Okay. Again, notice the new theorem: all right angles are congruent. Be able to use the right angle congruency theorem. Again, I don't care if you remember 2.3, but be able to use the right angle congruency theorem in a proof that says if two angles are 90 degrees, then the two angles are congruent. Let's keep going. Here we're given two more. We're given two more theorems to use in geometry. Congruent supplements. Remember that a supplement is two angles that equal 180 degrees. If two angles are supplementary to the same angle, or two congruent angles, then they are congruent. So we're even given a little a conditional statement. If angle 1 and angle 2 are supplementary, and angle 3 and angle 2 are supplementary, then angle 1 is congruent to angle 3. And what that does is that shows us we can just cross off those angle 2's because angle 1 is supplementary to it, angle 3 is supplementary to it. We can use the transitive property to prove that angle 1 is congruent to angle 3 because they're supplementary to the same angle. The same thing applies to the complements. And remember, a complement is two angles that add up to 90 degrees. If two angles are complementary to the same angle, or two congruent angles, then they are congruent. Just like if angle 4 is congruent to angle 5, or angle 4 is complementary to angle 5, if angle 6 is complementary to angle 5, we can use the transitive property to prove that angle 4 and angle 6 are congruent. But if you were to use this in a proof, notice how we have two different statements first. In both of these, we have, let me erase these so that you can see it. In both of these theorems, we're given two statements. a biconditional statement, if you will. We're told that angle 1 and angle 2 are supplementary. That's 1. 3 and 2 are supplementary. That's 2. We're told angle 4 and 5 are complementary. That's 1. Angle 6 and angle 5 are complementary. That's 2. Before you can use this statement and say that they're congruent, you have to prove that both pairs are supplementary. Wrote a little note down here. Notice that you need to prove two things in each of these theorems before you can say the angles are congruent. You need to prove that they're supplementary, and you need to prove that they're congruent to supplementary angles. So again, be able to prove that angle 1 and angle 2 add up to 180, be able to prove that angle 3 and angle 2 add up to 180, then you could use the transitive property to say that angle 1 and angle 3 are congruent by the congruent supplements theorem. Let's keep going. And again, I know that this is a lot to process. That's why you have these down in your notes. That way you always have a place to refer back to. Example 2 wants us to write a 2-column proof. So here we go. With our steps and our reasons. And what we want to prove, whoops, I don't know why I did that. What we want to prove is that angle 1 is congruent to angle 3. What we're given is that angle 1 and angle 2 are supplements. That's given. We're also given that angle 3 and angle 2 are supplements. That's also given. So before I go any farther, what I want to do is I want to say that if angle 1 and angle 2 are supplements, I was told that. I'm going to pull out right away and I'm going to say angle 1 plus angle 2 has to equal 180 degrees. That's the definition of supplementary angles. Right away, I'm taking what they told me was true and I'm running with it. I'm saying, all right, if they're supplementary, then the definition of supplementary angles says that they add up to 180. You might be thinking to yourself, duh, I already knew that. You're right, but write it down because it might come in handy. It's better to write too many things down in this proof than not write enough down and not be able to solve it. I'm going to write the same thing for 3 and 2. Angle 3 plus angle 2 equals 180, and that's the definition of supplementary angles. Now if I look, I've got two statements here. Angle 1 plus angle 2 equals 180. Angle 3 plus angle 2 equals 180. I've got two statements that are very, very similar. Both of these equal 180. So couldn't I just cross them off and set them equal to each other? I can. I can say that angle 1 plus angle 2 equals angle 3 plus angle 2. And the property that allows me to say that is the transitive property. Now, I don't really care what angle 1 plus angle 2 equals or what angle 3 plus angle 2 equals. What I eventually want to get to is that angle 1 and angle 3 are congruent. And so what I'm going to do is I want to get rid of these 2's on both sides. So I'm going to subtract angles. I can do that. I can really do anything. Using the subtraction problem, or property, I can subtract angle 2 from both sides. When I do that, I have angle 1 equals angle 3. Well, if two angles are equal, then they're also congruent. That's the definition of congruent angles. If angle 1 is equal to angle 3, then I can write angle 1 is congruent to angle 3, and at that point I'm done. And again, let's look. I mean, that took 1, 2, 3, 4, 5 steps. Not all that tough. What did we use? We used the definition of supplementary angles, something that you should know. We used the transitive property, something that you've used multiple times, and you will continue to use need to know. We also used the subtraction property, the definition of congruent angles, and then we were done. Okay. Again, the more you work with proofs, the better you'll get at them. Now let's go to a new postulate that you're going to learn. Linear pair postulate. Now you've been exposed to a linear pair. Okay? A linear pair is a pair of adjacent angles that are supplementary. If they're supplementary, then they equal 180. This is just a postulate explaining that. If two angles form a linear pair, then they are supplementary, blah, 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 blah. We already know this. Angle 1 and angle 2 form a linear pair, so angle 1 and angle 2 are supplementary, and angle 1 and angle 2 equal 180. That's very, very simple. That's the definition of a linear pair, definition of a supplementary angle. We're also told that vertical angles are congruent. I told you that at the beginning of the year. But now you have the theorem that backs it up. And now you can start using it in a proof. Let's actually use these two pieces of information to solve a couple geometry problems. In example 3, we're going to use linear pairs and vertical angles here. In example 3, we're told that angle 1 is 112 degrees. And we are told to find the measure of angle 2, the measure of angle 3, and the measure of angle 4, using vertical angles and linear pairs, or supplementary angles, however you want to say it. Well, now there are a couple different ways to go about this. The first thing that I'm going to do is I'm going to identify vertical angles. Vertical angles are congruent, so as soon as I can identify vertical angles, I can start saying stuff is congruent to each other. The first thing that I see is that angles 3 and 1 are congruent. Well, if 3 and 1 are congruent, then they have to be the exact same. If angle 1 is 112, then I know that angle 3 is 112. That's one thing that jumps out to me. Another thing that I see is that angle 1 and angle 2 form a straight line. That means that angle 1 plus angle 2 equals 180. That's the definition of a supplementary angle or a definition of a linear pair. Well, if angle 1 is 112, then I should be able to use subtraction and find out that angle 2 equals 68 degrees. So far, I've discovered, using just linear pairs and just vertical angles, that angle 1 is 112, angle 2 is 68, angle 3 is 112 because it's a vertical angle. And there's one more thing that should jump out to me, and if it hasn't already, it should right now. Angle 2 and angle 4 are what kind of angles? They're vertical angles. And if vertical angles are congruent, then whatever size angle 2 is has to be angle 4. If angle 2 is 68, then angle 4 has to be 68. Not too bad. Using just vertical angles and just linear pairs, I was able to take one piece of information and find out 3 missing pieces of information. I want you to practice using number 2. Number 2 starts off saying that angle 2 is 67 degrees. Using the same ideas we used in number 1, pause the video and solve for angles 1, 3, and 4. Alright, hopefully you had enough time to take what information we were given in number 2. We were given that angle 2 is 67 degrees. So we wrote angle 2 is 67 degrees over here. And hopefully you were able to take that information and apply it. Well, the first thing that I did was I proved vertical angles. If angle 2 and angle 4 are vertical angles, which they are, then they are congruent. I substituted angle 2 with 67 because that's what they equal. I can substitute it. Again, a substitution is like saying, hey, give me your $5 bill and I'll give you 5 ones. It's a substitution, but they're the same thing. I took out angle 2 and I put in 67 degrees. And angle 4 and angle 2 should still be congruent, so angle 4 should equal 67 degrees. Well, I can write 67 degrees right above angle 4. So far I figured out 2 angles. I've got 2 more to figure out. The next thing that I'm going to do is I'm going to identify linear pairs, or supplementary angles. And I used angle 1 and angle 2. I said angle 1 plus angle 2 equals 180. Then I substituted angle 2 and 67 degrees and said that angle 1 plus 67 degrees equals 180. I can do that because angle 2 equals 67. And using the substitution property, I can take out something and put in its place something of equal value. Well, then I subtracted 67 from both sides so that they would cancel out, and I got angle 1 to equal 113. Then I said, you know what? Angle 1 and angle 3 are vertical angles. And they're congruent. So angle 1 is congruent to angle 3. Then I substituted angle 1 with 113 because I knew it equaled it. And I can take out something and put in its place something of equal value. That's what the substitution property allows me to do. Then I can say, well, if angle 3 is congruent to 113, then angle 3 equals 113. And so I was able to take angle 2 being 67 degrees, and using vertical angles and linear pairs, I was able to solve for the other 3 missing angles. Right now, that's as far as we're going to go. If you want to work on example 1 or example 3, problem 3, go ahead. If you think that you need more practice, feel free. Okay? But the rest of us are done with section 7. Now, again, if you need more help, if you need more practice, here is a problem that you can work on. They gave you angle 4 is 71 degrees. Use vertical angles and linear pairs to solve for angle 1, angle 2, and angle 3, using exactly the same methods that we used in number 1 and number 2 of example 3. Otherwise, let's look at our homework.